Okay, this is your new chapter and it is about electromagnetic wave. So I would like to start this chapter by doing the introduction. Okay, we have learned before that when a current is passing through a conductor, then this current will create a magnetic field around the conductor. Okay, so that is the things which we have learned in the magnetic effects of current. Okay. Similarly, if you remember in electromagnetic induction that the EMF which is induced in the coil is written as minus d phi upon dt. Okay, where E stands for the EMF induced and this d phi upon dt is the rate of change of magnetic flux. But this EMF, it is a potential difference only. So for a potential difference, I can write it as E dot dl, which means this is equals to ddt of, now what is phi? Phi is the magnetic flux. So for the magnetic flux, I can say it is equals to BA. Okay, so the product of magnetic fields and area is the magnetic flux. Okay, ddt of B, what does it mean? It means that the magnetic field here is changing. So this changing magnetic field will produce an electric field. Okay, so that is how I have written here that a changing magnetic field or a varying magnetic field always produce an electric field. The question now is, if magnetic field, if a changing magnetic field produce an electric field, now the question is, can't we get a magnetic field from a varying electric field? Okay, this is number 3. Can varying electric field produces magnetic field? Okay, so this is a big question mark. And the answer to this question is yes. This varying electric field produces magnetic field was discovered by a very famous scientist, Maxwell, in the year around 1865. Okay, so Maxwell found that when electric field varies with time, then it produces a magnetic field. Okay, now later on, as Maxwell study about the experiment, he found that the Ampere's law, that is the line integral of a magnetic field around any closed path, which is equals to mu naught I, where I here stands for the current which is enclosed by the path, like in this case. The magnetic field around this closed path is equals to mu naught times the total current I, which is enclosed by the path. So this equation, it has a little bit problem, or I can say there is a deficiency of this equation. When you introduce a capacitor in the circuit, you will find, right, in the upcoming videos that this equation is insufficient. And so that is why Maxwell says that Ampere's law is inconsistent. And so he modified the equation and we name that equations after modifying as a modified Ampere's second law. Okay. So in this chapter we shall also study about Maxwell's equation. These Maxwell's equations, they consist of 4 equations, and these 4 equations are very important. So with this Maxwell's equation, we will study about the nature and the characteristics of the electromagnetic wave. Okay. Maxwell also, he further studied that the electromagnetic wave always travels with the speed of light. When I say speed of light, it means 3 into 10 to the power 8 meter per second. So this is the velocity of the electromagnetic wave. So if the velocity of the electromagnetic wave is the same as the speed of light, then light is also an electromagnetic wave. Okay, so this is just about the introductions of the electromagnetic wave, and in the next video we shall see about the inconsistency of Ampere's law And then next we will go to Maxwell's equations, and then we will study about the electromagnetic wave and its nature and property.